our goal is to program this batch simulator with the recipe I've already described. So let's start off by realizing that the way to do it is to make a recipe, basically make one step happen, then the next, and so on and so forth. And so we need to somehow capture our desired recipe so that we can make this work properly. So our recipe will basically consist of several steps, and one good way to organize this type of problem is to consider what all the inputs will be and what all the outputs will be. So if you think about what's going on with the inputs, say once the tank is full, if we detect that the tank is full, then it's time to say mix, for example. Okay, so that's an input that then drives the next step for the output. Now, a lot of these inputs will not be on-off inputs that are coming from a sensor necessarily, but things like counters or timers. As we noted, as the flow comes in, say through pump 1, the flow meter ticks off how much volume has gone into the container, into this tank. So if we count that, somehow we have to count, keep track of the flow meter tick so we can count how much volume has flowed into the system. So there's several different inputs. One of the inputs is the low level, because eventually I'll have to pump all this stuff out, and I want to detect that the tank is empty. And so the easiest way to do that is with the low level switch. Okay. Now, as I said, I'll have to have some counters as well. So I'll have a counter, we'll call it counter 1, and we'll say when it's done, I want to have things happen. So what do I mean by that? Well, counter 1 is going to count up the flow that comes in flow meter 1, and that way once I've applied the amount that I want, which I think I said I wanted 100 units from pump 1 and 200 from pump 2, once that counter is done, I want it to trigger different outputs. For example, once that counter's done, I want to shut off pump 1. I don't want more to come in once I've got 100 units. Now, similarly, I will need a counter for the other pump as well. Okay, so I want both of those to have counters associated with them. And I'll want to pre-mix. So once I've got the stuff, whatever these chemicals are, once I've got the chemicals in the tank, I'll want to mix them for a certain amount of time. Now, a lot of times it's a bad idea to use a timer when you should use a sensor. In this case, I don't have any choice, right? I don't have a sensor to tell me when the two components are completely mixed. It may be difficult, depending on what they are, to even make such a sensor. But, on the other hand, it may be possible. In this case, I don't have anything that will allow me to detect when the mixture is homogeneous. I'll just have to mix it for a certain amount of time. After that, the thermostat is a device that will tell me when the temperature has been reached. Because after I'm done pre-mixing, then what I'm going to do is turn on the heater. Once that heater has brought the mixture up to the desired temperature, the thermostat will kick on. And then finally, I'll want to mix it again afterward. That's what I decided. This is a recipe that's somewhat arbitrary, but I was just trying to get several steps in it. And so that will be our inputs. Now, I always like to leave a little bit of space between the inputs and outputs. Another thing that's going to happen pretty quickly is that this row is going to make my spreadsheet get really wide. So pardon me for a second while I fix the format. So let's format cells, and we'll make the text go at an angle instead of like that. There we go, that's better. So now this won't get wide so quickly. Okay, so now what outputs do I care about? Well, I need to control pump 1, I need to control pump 2, and the output pump, pump 3. All of those are outputs that I'll want to trigger at certain points during the recipe in order to make it work. I will also have to have a timer. Now, the mix timer is something I'll have to somehow start at some point. Once we've gotten to that place, right, and the inputs all say we're at the place where we need to start mixing, because we've filled with, apparently filled with enough product or enough reactants, well, then we'd want to start a mix timer so that as the mixer runs, we can count how long it's running. So I'm going to include a mix timer and another mix timer for after the product has been heated up. Let me open up my spreadsheet a little bit more so you can see it. I'll show you some tricks for dealing with Excel also here in just a moment. Okay, so I need two mix timers because I have potentially two different amounts of time that I want to mix, to blend at first and then to mix up the stuff after it's been heated. And that might be to drive the reaction to completion or whatever. It doesn't matter. And as I said, this recipe I've made up that I've defined is somewhat arbitrary. I don't know exactly what we're supposed to do here. It doesn't really matter. Now, I will also, since I have a counter over here, I have to somehow trigger that counter to count, right? So once I count up all of the flow, well, then I need some way to reset that counter for the next batch, right? Because I want to put batch after batch into this, react them, and then send them on their way. So I will need another output that will be to simply reset each counter. I'm going to copy that and paste that so it goes a little quicker because I want to change that to counter 2. There we go. So I need a way to reset both counter 1 and counter 2 so that when the next batch comes in, those counters are fresh and ready to keep track of how much comes in. Obviously, the mixer is an output that I need to control, and the heater is another element that I need to control. Now, let me show you a trick. See how this has gone off of the side here? If I highlight this section and double click, it will automatically scale all of that so everything fits. So now everything's nice and compact. There's more I will have to add to this later, but for now, let's just consider this and what we would want to do. So step 1. At step 1, what would we do? Well, let's see. In the very first step, what I want to do is detect that I'm in the first step. So if the low-level sensor is off, because remember the way this low-level sensor works is once we get some liquid in, then it turns on. So when it's off, that means the tank's empty. Well, if the tank's empty, I want to go ahead and turn on pump 1. So I'm putting a 1 there to indicate that I would turn on pump 1. Okay, what's going to happen next? Well, of course, the level sensor is going to turn off, but what I'm really interested in, the event I want to recognize and remember, is that counter 1 will be done. Remember, counter 1 is keeping track of how much flow has gone into the tank from pump 1. And so keeping track of that is really important. When it's done, that means I need to shut off this pump. Now, in most of these outputs, it's important that you put the 1 in for turning it on. It's also important that you put the 0 in for turning it off. I'll show you why. I'll describe it quickly. We're going to use latch and unlatch commands, and there's a reason for that. I'll try to describe it as we go. But for right now, just understand we need to put a 1 in for turning something on, a 0 for turning it off. That won't be true of the counter resets or the timers. They will naturally shut off, but we'll see that later. So once pump 1 has put enough fluid in, then I want to turn on pump 2. Okay, so what will pump 2 do? Well, pump 2 will start pumping fluid in, and what that will make happen, oh, by the way, that was step 2, by the way. What will happen then in step 3 is that the other counter will be done, right? Because the other counter will be tracking flow meter 2, and once the pump has put enough material into the tank, the 200 units or so, well, 200 units exactly, then I want to shut off pump 2. But what's next? Well, I said I wanted to mix it, right? So I need to start mix timer 1, but I also need to turn on the mixer. Now, I'm not going to turn on the heater yet because I want the heater to come on after the two reactants are well mixed. Okay, so we've got two things that we're turning on in this particular step. Sorry, I've actually already gone through all this, and I want to make sure it comes out easy to understand and so forth. So, yeah. So we'll leave it like this for now. So I want the timer to start, and I want the mixer to run. Okay. So what will happen in step 4? What input will change? Well, once the mixing is gone on for enough time, mixer number 1 timer will be done, right? And when that happens, as I said, I won't have to shut off the timer. The way I'm going to program it, it'll shut off automatically, but we'll see that in a second. So what I want to do at this point, I want to turn the heater on. Now, the heater can cause reactions to occur at the bottom of the tank, and the heat maybe never get up, or the thermal energy never get up to the top, where the reactions can occur everywhere. So I'm actually going to leave the mixer on during this step. So then what happens? Well, what is the condition for shutting the heater off in particular? Well, if the thermostat comes up to temperature, then it would be time to shut off the heater. Okay, so let's put a 0 there for shutting off the heater, but I want to leave the mixer on because the mixer needs to continue mixing, and if we're mixing now in the period after the thermal energy has been added, if we're driving the reaction to completion through mixing, then I want to also start another timer, right? I want to start the second mix timer. Okay, that's fine. Now this would be step number 5. And so what would happen? Well, the next step, which would be step 6, is that the second mix timer will finally be done. Once that timer is done, well, then it's time to start over, right? So at this point, we should shut off the mixer, reset the counters, and go back to the beginning, right? So let's put 1s in for resetting the counters. Notice that pump 3 hasn't done anything yet. Well, what I really want to have happen is turn on pump 3, because after we're done mixing the second time, then we want to get everything out of the tank. What's the condition then for going on to the next step? Well, once the pump pulls everything out of the tank, the low-level sensor is going to go back to 0, and we'll be back at step 1. Now notice there's one other thing I need to do. I need to shut off pump 3. So I can't forget to put that 0 in because step 6 rolls back around to step 1. You could simply just copy this whole sequence and paste it down below, and it just goes on forever. But understand, all I'm doing is wrapping back around to step 1. There's actually a bug already introduced, and I'll show it to you as we go through. You have to really be careful with this method to figure out how things should work. Now, the problem is I can't just look at counter 1 done, know that means to turn on pump 2, and somehow remember what step we're in. What we'll have to do, the PLC is very dumb. We have to somehow remember everything for the sake of the PLC. So we're going to use some memory bits to do that. We're going to remember that events have occurred. I was thinking at first I would need 6, but it turns out I'm only going to use 5. You'll see why in just a minute. You could use less. Since there are only 6 steps, technically all you need are 3 bits. But it's a little more complicated programming it where all possible combinations of bits are used. Of course, 6 out of 8 is not using all the possible combinations, but it's a little more confusing. And since memory is cheap, I'm just going to go ahead and insert 5 columns. And in these columns, I'm going to put in some new inputs. You see, the memory bits will serve as both input conditions and outputs, because once the input conditions have been met, we need to set the outputs, right, turn on pumps and so on, but we also need to remember that we've reached that step. So let me put in bit 1, bit 2, bit 3, bit 4, and bit 5. And since these are also inputs, I'm going to, let's see, 1, 2, 3, 4, 5. I'm going to insert some columns and copy these bits over here. Let's just paste. Now, again, I want to manage all this and keep it nice and compact, so I'm going to highlight the sections that are too wide. There we go. And to make this look nice and make it clear, I'm going to make the outputs all merged cells, so the word output is above all the outputs. I'll do the same thing with the inputs. So again, this fits nicely on the screen. I just realized you may not be able to see this very well on the video, so I'm going to increase the size. There we go. You'll be able to download this spreadsheet too. So the bits, these memory bits, are going to serve as inputs as well as outputs. So we have to consider them in each step. And we can set them up however we want. I'm going to use bit 1 for the first step, bit 2 for the second, and so on. So basically these bits are going to start off as inputs that are off, right? When you start the program, these memory locations and the actual addresses, I'll show you a little bit later. Right now I'm just calling them bit 1, bit 2, and so on. These memory locations will be off by default. Now, once we see that we are in this step, that's what these bits do for us. They tell us what step we're in. Once we see that these bits are off and the low-level switch is off, that's when I will want to move to the next step. So what I want to do is turn on bit 1, so I don't really need these. Let's clear the contents. Let's see, I thought they had, there it is, clear contents. That's when I want to turn on bit 1. Of course, at that time, I'll also turn on the pump. I'll turn off pump 3 in case we're repeating already. And what will happen is we'll go to the next step. What would the next step look like? Well, it would look like this. All the other bits would still be off except for the one that I turned on, you see. So that's fine. So then I'll be in this step. Now understand, in this step, what I'll have to do is make code that waits to see counter 1 done, but this pump will be running the whole time. So as the pump's running, mechanically that'll cause the counter to increase, right? Because the flow meter is going to be triggered, which is going to be driving the counter. And finally we'll get to the point where the counter's done. In other words, we've got, I didn't want to do that, we've got all of pump 1's product into the, or reactant into the tank. So at that point I'll want to turn on the next bit, right? I want to shut off pump 1 because I've got plenty in the tank. I'll turn on the other pump to put the other reagent or reactant into the tank. And now in the next step, you see that pump 2 is on. I'm in the next step because I turned that bit on. I didn't turn off bit 1. Okay, there's no need. You could, but I like to set it up this way. There's actually a lot of flexibility here. There's many different ways to do this, but I'm going through the way that I think is the easiest to understand. So we'll be in this step, and when we see that counter 2 is done, what does that mean? Well, that means that pump 2 has done its job, right? That means that all of the product I wanted has come in from pump 2. At that point, I'll want to turn on the next bit, indicating or remembering that an event has occurred. The event is that I've put all, or I guess the event is that I've finished that step 2, right? I'm sorry, step 3. And so then what I want to do is turn off pump 2. That makes sense. I don't want any more in it. And I'll turn on the mixer. That's right here. I also need to start the timer for mixing. Okay, so far this looks good. Now, what will happen if I run this timer is that, let's see, I guess the bit pattern will be like this. There we go. What will happen eventually is that timer will be done, right? The time will have run out. When that happens, I want to leave the mixer on, but turn on the heater. Now remember, I don't have to shut off the timer. It'll turn off automatically the way I'm going to do this. Okay, and at that point I need to set bit 4, indicating that I've reached step 4. So in looking for step 5, I'm sorry, I meant that bit 4 would indicate that I've completed step 4, and now I'm looking for step 5, right? So the bit pattern will be like this, indicating that step 4 is done. We're waiting for step 5 to be done. Step 5 is that the heater brings the temperature up to the desired level. Now that we're sensing from an actual input. The low level switch and the thermostat are the only 2 real inputs that we're using that's coming from a sensor. Okay, so once the mixture has come up to temperature, then I'll realize, or I'll remember, that step has been completed by putting a 1 into bit 5. I'll start the mix timer, I'll let the mixer keep going, and I'll shut off the heater. So now I'll be looking for step 6 because all the bits are on at this point. And when the timer is done, right, because these 5 bits here indicate that all 5 steps have been completed. So once we see that all 5 steps have been completed, and, that's going to be a logical and the mix timer 2 is done, well then we need to shut off the mixer, reset the counters, okay, because we're going to pump everything out of this tank. Now you could actually reset the counters a couple of different places. You could reset them up here, let's see, just before pump 1 runs. I'm going to leave it right here because I think conceptually it's the easiest to understand. But there's certainly one thing you want to do. You want to go back to step 1. How do you do that? Well, you reset all of the bits. So I will have to have a rung of ladder logic that says, given these conditions, reset all of these bits. And I just noticed that one's a little too wide. There we go. As a matter of fact, looks like this could all use a little bit of optimization. Well, I guess not. Maybe I could zoom in a little more and you can see. So this is my sequence of events. This is what I want to have happen. When I see this input pattern, I want to trigger these things to happen. Okay, and if I do that, everything should work. Actually, there's one bug. It has to do with the timers. I'll show you what it is as I program it. So as you're going along, make sure you're following along with me and making all of this work. So how do I do this? Well, the first thing I'm going to do, you notice I didn't include the start and stop button in the sequence. That's because the start and stop button are not involved in the repeating sequence, right? They are inputs that should control the overall process. For using the start-stop buttons, I'm simply going to use the standard seal-in circuit with a normally open start button and a normally closed stop button. Okay, so if I do that, I'll drag these over. It gets difficult very quick to remember what all these addresses are, so it's very important to name them. I'm going to use the run lamp as my seal-in, and that way I can turn the light on also. Now notice what I'm doing is right-clicking and saying Edit Symbol. I'm going to call this Start PD for push button, and note that it's normally open. And for the stop button, that's the stop push button, which is normally closed. Okay, now this doesn't do anything yet except for seal in the run lamp. Okay, well, what would I like to have happen? Well, when we're in run mode, I would like the process to start running. So really the run mode is a condition for most of the rungs. I'm not going to use it as a condition for all of the rungs, but I'm going to use it for most of the rungs. And all I really have to do is look at my sequence of events and start programming based on that. Now, it's a little difficult to see, so what I'm going to do is start by going back and forth. Let's see, I guess, you know what, let's do this. So that I can name everything, I'm just going to put all of the outputs on one rung, reference the number, and name them so that I can keep track of what's what. Let's see, we've got 1, 2, 3 pumps, a heater, and a mixer. That's 5 outputs. We've also got these lights. I'll deal with the lights a little bit later. So let's see, 5 outputs here. We'll drag addresses to make life easy. So that's 2, 0, and that's the mixer. If we drag in, let's see, pump 1, that's the next address, so pump 1. We'll drag in also pump 2's address. Make sure we name it, pump 2. And then, of course, let's not leave out pump 3. Got to drag the address itself. You can type it in if you want. I find it easier in these simulators to just drag and drop. Of course, in the real world that doesn't work. But it's just as important in the real world that you label your outputs and your inputs as well so you know what's what. And then finally, the heater is on output 2, 4. Now, one thing I would do if I had a little more time, but I'm trying to make this video short, one thing I would do, I would actually include all of the addresses in another row. That's very handy. I'm not going to do that right now because I'm trying to save time. There are a bunch of other bits that I'll want as well. I'll need to define some memory for bit 1 through 5. So I'm going to use the very first word in binary memory. And to keep things simple, I could use bit 0, but I want the bit numbers to match the bit name. And notice I didn't start from 0. I could make it a step 0, but it's easier to think of step 1, 2, 3, 4, etc. So I'm going to cheat just a little bit. I'm going to paste right a couple of times. That'll go a lot quicker. I probably should have done that with the outputs above, the actual outputs. Whoop. Paste right. There we go. And then if I change these to bit 2, there we go. Notice I have to change the address first. If I change the label first, this label is still associated with this address. It'll mess this one up. I don't want to do that. So let's see, where were we? 3. Now, if you don't change the label, Logix Pro will make it look like it remained bit 1, or the label B1, but when you run your code and download it, it'll get rid of the label. So there's also some bugs in Logix Pro. A very good habit to get into is, whoop, that should be bit 4. A very good habit to get into is to download and run your code often, or at least download it often to the PLC. If you don't do that, certain operations in Logix Pro will actually clear all of your target values in your timers and your counters. So, in other words, the preset values. It'll clear those, and you'll wonder why your program's not working. Then you'll look and you'll see all your timers and counters don't have a preset value or have a preset value of 0. So I just wanted to name these quickly. I think I've got most of the sensors. Maybe not. This is not code that I'm writing. I'm just putting stuff in here so that I can keep track of everything. Let's name this low level. So that's our low level switch. We'll just leave it low level, that's fine. Let's see, we've got a couple of flow meters as well. I want to keep track of those. So I guess that would be, for example, I:1/5, and that would be flow meter 1. Now I'm going to be clever here and copy this and then paste right. And then if I change the address to 6, that's flow meter 2. And then paste right. Again, I don't have to copy again. If it's still in the clipboard, 7 would be flow meter 3 on the outlet. Okay, so now the flow meters are labeled. The low level switch, oh, there's a thermostat also. So let's paste left, make it I:1/2, which is the thermostat, and name it thermostat. Okay, so I think I've got the bulk of this in place. I don't have any switches for the timers and counters because I haven't created those yet, but that's all right. We'll do that a little bit later. So in run mode, what do I want to have happen? Well, the first thing I want to have happen is I want to look and see if the bits are all off. If they're all off and low level is true, then I want to turn on bit 1, turn on pump 1, and turn off pump 3. So let's do that. So the conditions for our first, let's see, yeah, we can do this, B:0/1, is that it's off, right? So if B1 is off, the inverse of that is on, so that's what will allow me to create a true value in B1 and a true value in pump 1, and to also activate turning off pump 3. I'll show you how that works in a second. So let's copy this. We'll paste left, paste right, doesn't matter. I need 5 of them, and I'll probably start copying rungs so that I can avoid putting these on every single, pasting them on every single rung. But I just need to see that all of the bits are already off. When I see that they're already off, this is an AND condition, right? Bit 1 and bit 2 and bit 3 and so on are all off. Then what I want to do is turn on bit 1, turn on the pump, and turn off pump 3. Here's how I do that. I could put them all in a row, and it would make the code look a little smaller, but I prefer to put them in OR branches. And what I'm going to do, I guess I'll just start dragging these up and making them what I want. So I want to turn on this bit, but I want to latch the bit on. So I'm going to right-click that and make it a latch instruction. And I'll also want to turn on pump 1. Now pump 1's right here, so I can just drag and drop. And I'll also want to latch it. Now the reason I'm latching is because if all these conditions are true and this one then changes, that's going to flip this bit. And so if this was just a regular output instruction, the pump would turn on for one scan and then turn off. I don't want that. I want it to stay on. That's the reason I'm using latches here, and that's the reason I have to remember to turn the pump off as well. That's the reason for these zeros. It'll be the same story for the mixer and the heater. Okay, so there's one more condition for this though. There's one more input, and that is that the low level needs to be off. So let's take the low level switch, put it here, and change it. Okay, there we are. Now I'm forgetting something. Oh yes, I have to shut off pump 3. So drag and unlatch. I could have dragged this instruction, probably should have, but that's okay. There it is. Okay, so this first rung represents this row. It's step 1. I forgot my step text. That way we know what our step numbers are. And what I want to do in this step is turn on bit 1, turn on pump 1, turn off pump 3. That's what we're doing. We know we're in the step. We know that all the conditions are made because these are the conditions and they're ANDed together, and we're going to make this all happen that time. Now understand that this rung will only give me a true signal for one scan, because as soon as it gives me a true signal, this bit is going to turn on, meaning that this condition is no longer met, right? Because a 1 inverted is a 0, and as soon as you see a 0, nothing else is going to happen with this rung. But that's okay, I just need it on for one rung. So that should take care of my programming for the first row. Let's try the second row. For the second row, I'm going to need a counter. Now, what is that counter doing? Oh, by the way, let me edit the rung comment before I forget it. Let's see, this is step 1. Well, the next rung is going to depend on a counter being done, and I don't have a counter yet, so let me go ahead and create a rung with a counter. So I'll insert a new rung, I'll put a counter, it's a count up counter, and I'll just define an address C:0, that should be fine. And the preset is 100 because I want 100 ticks or 100 units from the flow meter to come in. So that would be from input 5. So as the flow meter detects flow going through it, it'll count up volumes of flow, and this counter will count up volumes of flow, right? Because every time that flow meter ticks off another volume, the counter will count it. Okay, so that's good, and I'm not going to make this run with or without the run mode. I'll just leave it off, I guess, because this should always happen, right? The flow meter, if there's flow for any reason, I'd like to count it. So I'm going to leave it that way. Now I've got a counter that can be done. It's this C5:0. Let me copy this rung for the sake of speed and paste rung below. Now I'm going to edit the rung comment, and I'm going to turn this into step 2. I want run mode in, and what do I want to have happen? Well, the conditions are that bit 1 be on and that counter 1 be done. Okay, so bit 1 needs to be on, so let me change this. There we go. Now understand that changing this instruction doesn't change bit 1 to on, it just detects when bit 1 is on. This instruction detects when bit 1 is on. This one determines when bit 2 is on, or is off. This determines when bit 3 is off, all the way through bit 5 being off. Now I don't want to deal with the low-level sensor on this. What I was trying to do was reference the counter being done. Now, from your previous experience, you may think all you need to do is this, C:0. That's not. In this language, you have to put the done bit, which particular bit you're interested in. And actually, what I want is for that to be true. So when this counter is done, this bit will turn on automatically. That's what this counter will do for me. And now my conditions for step 2 are completely met. Bit 1 is on, the rest of the bits are off, and the counter is done. In that case, I want to turn on bit 2 to remember that I have finished step 2. I want to turn off pump 1 and turn on pump 2. So let's change the latching instruction to turn on pump 2. We want to turn off pump 1. I should have dragged that one first. And we want to latch on bit 2. So just like the previous step, this rung will only be true for one scan, because as soon as I turn this bit on, well, then the inverse of on is off and the signal no longer gets through. But that's fine. That's all I need is one scan. And so what will happen, let's make sure this works. Pump 2 comes on, pump 1 goes off, check. That should be good. Okay, so what happens next? That's step 2. Let's take care of step 3. In step 3, we fill with the other pump, right? So bit 2 is on. Let me copy this, and I will paste rung below using the same trick for the sake of time. Edit rung comment. This will be step 3. And I will want to see, oh, I forgot to name this. Edit symbol. This is pump 1 done, let's say. Okay, so if I make this reference another counter, which of course I've forgotten to create, this would mean pump 2 done. Of course, we'll have to make a rung to recognize that, but the other thing I need to do is change bit 2, because look on this step. Bit 1 is on, bit 2 is on, the rest are off, so that matches. Bit 1, bit 2 on, the rest off, and the other counter needs to be done, and when that happens, I want to turn on bit 3. I want to turn off pump 2 and turn on a timer. Okay, so let's see. If I were to, let's see, drag this down, that'll turn on bit 3. Good. I want to turn off the pump, and I want to start a timer. Now, here's the problem. If I simply take a timer and put it in here, it won't work. Because this rung, remember, only stays true for one scan. We latch on bit 3, and so that prevents current from getting through here, this path, on the next scan. So the timer will just run for one scan, and that won't do me any good. Just like with my counter, I need a separate row for the timer. So what I'm going to do is start a new row. I'm going to put the timer on the new row, and instead of referencing all of this, understand that this timer should simply start running when bit 3 comes on, right? So all I need is something to reference that bit. And really, it'd probably be better, you know what, let me do it this way. Let me copy this rung, paste rung below, because really I only want that timer to run when all of the bits are set a certain way, right? In other words, let's cut all this stuff out. Let's see, cut that out, cut that, and cut this. If you have a delete key on your keyboard, you can just hit delete. My delete doesn't work quite that way. And I don't really care about it being in run mode. But when the bits are set that way, I think I want the timer to run. Let's double check that. Let's see. Actually, it looks like 11000. So let's do this. Now this is actually where the bug occurs. But since I put the timer on this row, you would think this would start the timer. The problem is that just like putting the timer up here, this is going to make it stop. So I'm going to go ahead and fix that bug now and realize that this rung is going to set bit 3. Oh, let me clean up the rung just a little bit. Come on. You have to pre-select the instruction that you want to move, and sometimes it doesn't want to move very well. You have to drag the instruction itself. Okay, so that won't work for the same reason that putting the timer on this row won't work. So let me change it. So now the timer should start running. And technically what that means is I have put this output on the next row. I'll need to do the same thing technically with this other timer, because the timer should actually be running with this sequence, right, or with this set of bits. That's when I want the mix timer to be on. Okay, now let's give this timer a number. T:0 should be fine. I'm just going to let it run for, say, well, let's make it 10 seconds. So 100 times 0.1 seconds is 10 seconds, because that's counting up, or it's timing tenths of a second. And let me not forget to also incorporate the other flow meter. So let me copy this. Let's see, I put it, where did I put it before? I put it after the step it's associated with, so, or before the done bit. So here's the done bit for the other one. Let's insert rung above. There we go. And it's the other flow meter I want to keep track of. This pumping in product 2. I'll need a different counter. I can't reuse the other counter. And I want to put 200 units of fluid from whatever this other source is into the tank. Okay. So far, so good. So we've got this timer, let's see, and that takes care of, let's see, we've shut the pump off, we've remembered that we're in, let's see, is that the right step? Yeah, we remember that we've accomplished step 3, so technically now we are in, let's see, technically this is step 4, but I don't intend for the step notes to be on the timers. That's just like with the counters. My goal instead is to detect the next step. So let me copy this rung. I'll paste the rung below. There we go. I don't think I need this instruction anymore. It's just there to remind me. And I'm going to keep that separation between those two so I can keep myself straight here. So let's edit rung comment, change this to step 4. So we're detecting step 4 now. So we're on this row. So when we see that bits 1, 2, and 3 are all on, and the other 2 bits are off, and what else? And the mix timer is done. Well, that's this timer, because it's the first mix that I care about. So T:0/done. Let's see, now this would be mix 1 done. When that happens, let's see, I want to turn on bit 4, turn on the mixer, or leave on the mixer actually, and turn on the heater. Did I forget to turn on the mixer before? Pump 2 off. Yes, I forgot to turn on the mixer in step 3. Let me add that in quickly. So let's add in an OR. We'll move this down. And where's the mixer? There it is. I'll just move that up. Change it to a latch. There we go. So now the mixer will be on in step 3. I won't do anything to it in step 4 because I want it to remain on. Rather, what did I need to do? I needed to, let's see, in step 4, turn on the heater also. And also, of course, remember that I'm in step 4. So if this is step 4, I need to turn on that bit, and I need to turn on the mixer. So let's add that in. I guess I've been a little bit inconsistent here. Tell you what, let's try to be consistent with the order in which we latch and unlatch. It doesn't matter, they all happen at the same time, but code is often easier to read if you just do things in the same order. So then it makes some sense. Okay, so I'll unlatch pump 2 here, but I wanted to, see, what is this, step 4? Oh, I wanted to latch the heater. So let's get the heater. There it is. Let's put it here, and let's latch the heater on. Now, did I need to unlatch pump 2? I don't think so. No, the pump has already been unlatched. I just needed to turn on the heater and leave on the mixer. So let's get rid of that instruction. Let's take this, move it up, and then get rid of the useless branch. It won't affect anything, but it's not useful, and it kind of looks like a short circuit. I don't want it to look that way. Okay, so that's step 4, assuming I haven't made any mistakes along the way. So the next thing is step number 5. Okay, so let's continue with step 5. To do that, I'll simply copy this rung. I will paste the rung below, and I will edit the rung comment to call it step number 5. There we go. And in step number 5, of course, this bit is already on, indicating that we have finished step 4. So what this really says, you can read it in English, we've finished step 1 and step 2 and step 3 and step 4, but not step 5. That's what we're trying to detect. And once all these conditions are true, then we have completed step 5, so we can do that. But what is the condition? Well, the condition really is that the last timer is done. Now, I don't have a last timer yet. Let me copy this and put it in, I guess I'll put it in above this rung to be consistent. And I will make this another timer. I don't want to reuse the old one. And to make sure that this works, I'm going to make this run for a different amount of time. Let's say for whatever reason we need the mixer to mix for 15 seconds after the step has been reached. Now understand that the condition here is that we're actually finished with step 4. That's the way I'm programming this. Remember, I put it down here. Those are really the conditions for driving it so that we can detect step 5. So anyway, where are we? Step 5, I believe. Yeah. So we're looking at conditions for step 5, and they are that we've finished all the way through step 4. Step 5 is not done, but the timer... Wait a second. We're at step 6. Hang on just a second. Let me figure this out. It's confusing with these timers, so that's what's throwing me off. What did I do last? I turned on the heater. Yeah, I turned on the heater last time. Now I need to turn it off. So let's not forget to do that. Let's turn off the heater because this indicates that we have reached temperature. So let's see, mixing's done. the condition should be that we have reached temperature. So let's take the address for the thermostat and put it here. Oh, I've skipped over a row, haven't I? That's what's wrong. Yeah, I've skipped a row because I jumped straight to the timer, but the timer needs to time the last mix. And so I have accidentally skipped step 5. I hope that doesn't confuse too many people. So I'll need to latch on, let's see, bit 5, and I will need to unlatch the heater. Yeah, so actually I should unlatch the heater here. There we go. And then this timer rung will need to go down below. That should be consistent. And so I'll actually want the conditions here to be all true, so that when all the bits are true, that's when the timer runs. But it's basically timing what we set up, the mixer start, right? It's timing that so that once it's done, then everything else follows. It's kind of like cascading. It's the same thing we did really when we cascaded timers for the sake of the traffic light problem. That was early on in the semester. You may not have remembered that. So we're just cascading, and when we get to the point where all the bits are on and the mix timer 2 is done, let's see, this would be mix timer 2. Let's see if we can name it that way. Let's just call it mix time 2. Or better yet, mix 2 timer. Similarly, we could name this mix 1 timer. Yeah, so I need a step 6. So let's copy this rung, paste the rung below, change this to the proper conditions, and now when mix 1 timer or mix 2 timer is done, which is T:1/done, DN. So this would be mix 2 done. When that happens, I'll be right here, right? When that happens, I will want to shut off all of the bits. I'll want to, let's see, turn on pump 3, reset the counters, and shut off the mixer. That's quite a bit. Let me show you how to do this. Let's start with the mixer because that's the easiest one. So let's see, the mixer, do I still have it down here? No, that's okay. I'll just type in the address. So that would be O:2/0. So I'll turn off the mixture. I don't really want to do this, right? I don't want to latch another bit. All the bits are latched at this point. What I really want to do is reset them all. Well, to be consistent, I'll do that at the end, and I'll show you one way to shut off all these bits at the same time. It actually shuts off more bits than these, but you'll see it in a second. It comes from resetting the counters. That's the other thing I need to do. And I need to turn on pump 3. So let's see. Let's be consistent. We'll put this down here. We'll turn on pump 3. So let's grab that, put it up there. We want to latch it on. And then we're going to need to reset both of the counters. Now, how do you do that? Well, there's actually a really nice instruction under timer counters called reset. What it does is it resets whatever you point it at. If I were to put C:1 here, it turns out in this language it wouldn't work quite right. It would actually reset the accumulated value of, or the count in that counter to 1 instead of 0. That's not what I want. I want to reset just the accumulated value. The accumulated value is the count. It's how many events the counter has remembered have occurred. It's the count, right? It's this value right here. I'll just show it to you. It's that value. Right now it's 0. We haven't counted anything. But as we count these events of the flow meter ticking off volumes of flow, eventually the accumulated value will reach 200 and will just sit there, right? Because there won't be any more flow. I'm going to shut it off. I'm going to shut off that pump. There won't be any more flow, so the counter will just sit there. Well, to repeat the cycle, I've got to somehow reset it. That's what this instruction does. Now, I want to reset the other counter as well, so I'm going to grab actually 2 more branches while I'm at it. You'll see why here in a second. pull this in. I'm going to make this quick. Copy, paste left. That's fine. Move it down here. And for this one now, I'll reset counter 0. Remember, I used counter 0 and counter 1 for measuring the flow from both pump 1 and pump 2. Now this gives me an idea. I would like to reset a bunch of bits at once, and what this reset instruction is doing is resetting an entire word. Well, why can't I just reset the B:0 word? I mean, think about it. This bit 1, 2, 3, 4, 5, these are all bits of one word. Let me show it to you. When you go into the binary file, it's literally this word. Now understand, this can have bad side effects. If I were using bits 6 through 15 of this word, this instruction will reset those as well. But I don't really care in this case. I would rather keep the code compact and reset all of those bits. And so that'll take care of resetting all the bits, of course, once these conditions are true. Whoop. Sorry, I scrolled down. So we'll reset all the bits. We will turn on pump 3. We'll turn off, the mixer. We'll reset both of these. And remember, this timer is just a side effect of really, we want the timer to run once we've reached this step and we're waiting for the last condition of the step to be true. So really, this mix timer is not dependent on this bit. It's dependent only on these bits. And you can see that, of course, right here. Well, actually, maybe not. I've got pump 1 or pump 2 done. I don't think that's what I want. Yeah, that's just a holdover from where I copied it. I forgot to delete it. So let's just cut those instructions out. Because the only thing it should depend on is what step we're in. Now, as soon as we get out of that step, these timers will automatically reset themselves. So I don't have to reset them like I do the counters. Okay. So we'll just leave these blank. We know what they're doing. That's good enough. All right, now I think we've done everything we need to. Let's go double check at the top. I may have forgotten to shut off pump 3. No, I remembered it. There we are. And so now let's check our run mode lamps. I think they're on all the rungs I want them to be on. Something very important I haven't done so far. I've lived very dangerously. I haven't saved yet. So let's save this. Now I've actually already saved versions of this because I wanted to get through the code as quickly as possible on camera so I don't waste your time. And unfortunately right now it's pointed at a network drive which is taking forever to respond. But let me just throw this on the desktop. You'll see I've got a couple of different versions here. And there's actually more I can do. Maybe I'll make another video showing you that. But anyway, let's just call this batch sequence. Well, I called it something else. Batch, let's just call it V1 for now. Now, Logix Pro is kind of weird. It doesn't update the name here, although that's the name. If you hit save, it's actually a save as. So is file save. It's file save as. And so you have to select a name and a location, all that, and you can just overwrite the code. Let's see if this works. Let's download it and run it. It doesn't do anything yet. Let's see, why are the bits not all set? You see how current is passing through this one, indicating bit 1 is off. Well, the other bits should be off as well. Oh, they're actually on. I could reset all of them, or I could use the same strategy that I used in resetting the whole word by literally resetting the whole word. Now, why are they coming back on? Okay, you know what? I wonder if I forgot to take out those. Yes, I forgot to take out these last few rungs. And so it makes sense. That's what's turning the bits on. I just completely forgot. Let's try again. Let's go to program mode. I had put those in to use and I forgot to take them out. I'd also want to remove this because I don't need any of this. And I'll take out the dividing rung also. Okay, there we go. Let's try that. So let's download it. Let's look in memory. Yeah, those bits are still on, so I'm going to change to decimal, reset those all at once to 0. Because a decimal 0 is a binary 16 zeros. There we go. So we'll download it again just for good measure. Looks like our counters or timers have their preset values. I think we're ready. We'll hit run. Okay, so now we've got all of this passing power. And so what should happen once I hit run mode is the pump should come on. Pump 3 should shut off. Of course, it's off already, but this is for when we cycle back around for this first step. And we will have finished step 1. So let's hit start. There we go. Okay, so the low level switch came on. You see the flow meter was running. It counted up to 100 units. We've got 200 units that have come in. Now the mixer has started. This is going really well. The mix timer is running. It should run for 10 seconds. And there we go. Now the heater came on. That's good. Notice the mixer is still on. And the heater needs to be on until we've reached temperature. My temperature was set for 32, so that's what happened. Now we're mixing for 15 seconds. There we go. So 15 seconds. There's 10, 11, 12, 15 seconds. And now pump 3 is on. We reached step 5. It's emptying out. And there we go. It's refilling. Let's see if it works through another cycle. So let's see, it fills up as long as it doesn't overfill. Good. Should be mixing. You know what? Let's play with this a little bit. Let's make the required temperature be quite a bit higher. Let's make it reach, remember it blew up at 100, so let's go to 80. See if that makes any difference. I think it'll just take longer for the sequence to complete. That's all that should happen. So once the thermostat says that we're there, we'll shut off the heater, go to the next step where the timer starts running for mixing. And there we go. Yep, timer running while we're still mixing. And once that timer's done, then we reset the accumulated values. Notice those accumulated values are not reset yet. And there we go. They've been reset, and of course the bits were sent back. So this is working. Now here's a question. What happens if we stop? And then start again? Well, if I had stopped and just let the simulator run, the pump would just keep going. So there are some definite improvements that would be wise here. When the operator hits the stop button, they actually expect for everything to stop, right? And instead, our pump just kept running. If I hit stop right now, the mixer keeps running, right? That's not good. The operator expects for stop to mean that things stop, not that they keep going. So really that's one improvement that we can make to this program. Another improvement would be make the idle and full values run. We could also use this counter here to count up how much there's in the tank. We could potentially use this batch mix here to decide how much goes into the tank. So I think I'll add a few of those things, but that'll be in a future video. This one's been long enough as it is.